Today we have finished the alpha build of the game First Principles. We added a brand new user interface that is very just intuitive and easy to understand. So if you press the play button, for now we haven't implemented any video game elements to our interactive module. However, the graph and the Cartesian plane, as well as all the transformations regarding the our graph, is just successfully executed in the sense that everything just responds in a manner that is expected. Let's try to change the power, the degree of the function to let's say 4. Or we can also plot a 5th degree function, or 6th, or 7th, or 6th. There's infinite amount of possibilities. As you guys can see, if there's a linear function, the derivative of the linear function is a straight line, as it becomes a constant. Actually very cool. So let's go with 3rd degree function. So let's try to switch the function type to exponential. As you guys can see, the exponential function works like a charm. And also there's natural exponential function, which the base becomes Euler's number instead of becoming the user set base. We also have the logarithm function, as well as the tangent function. The tangent function, for now, it doesn't look perfectly right. As you can see, there's extra line on this side, on the right side, but yeah, so far so good. Let's go back to the power function. So for derivative graph, if you apply the D transformation to the horizontal translation to the original graph, like let's try 5, you can see that everything is being applied to both the mapping notation on the bottom, as well as the graph itself. Let's try to apply a vertical translation now. Let's try 2, 3, 4, 5, 6, 2, 1. As you guys can see, it's very real. Like all the mathematical concepts are being applied to this model, in the sense that the vertical translation doesn't change the actual instantaneous rate of change due to it being outside of the bracket that covers the x value. The y, the vertical translation becomes obsolete when you're differentiating a function such as 4 over 10 x minus 1 to the power of 3 plus negative 2. If you guys know the power rule, it's fairly simple, it's fairly straightforward. And last but not least, we will try to change the range of the Cartesian plane. So here we're gonna go to the grid renderer, which is a script that manages the Cartesian plane in the background. By the way, everything is written by Rayan, Kaissi, and me. The scripts and everything, nothing's from the Access store, just in case you guys are wondering. So everything was written from the scratch, and in the sense that we've completely succeeded in executing this mathematical model of different functions. It's very meaningful. So now we're gonna go to grid renderer. It's located in the grid graph folder. If you guys are accessing our GitHub, we're gonna go to grid background. Okay, there you go. We're gonna try to change the grid size to let's say 52 by 28. So we're gonna go 52 by 28, and then if we try to 6 52, try to refresh it. Let's go to scenes. So if you go to games, and go to graph container, graph footer, grid, Cartesian plane, grid. So we're gonna try to apply something like 52 to 28. If we actually run the game, the graph aligns goes to a correct location, as you guys can clearly tell. 14. It's the possibilities are infinite. It's very cool, right? Amazing. We just have to implement the feature where the grid actively reflects the update. So that's something we should implement. But anyways, everything just works perfectly. And yeah, hope you guys have a good one. Thank you for checking out our devlog, and have a good weekend. Bye bye.